SBA, you guys will be able to use angle, angle, side, angle, and hypotenuse, leg to prove triangle square section 5.5. We had these triangle shortcuts last time, okay? We talked about those in our homework that we just checked. Side, 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 angle, side. We're going to go over a few others and see if they work today, okay? So the first one we're going to look over is angle, side, angle. Angle, side, angle, okay? So ASA. So let's say we have these two triangles again, okay? You guys remember using these triangles before? Mm-hmm. Okay, I hope so. Okay. So we had these. They are. So we have these. So let's say that these angles are congruent, and these other angles are congruent to each other, and we have these sides between them are also congruent. Okay. So we're trying to say, is there a way that we can manipulate these triangles, or even just one of these triangles, to where the triangles are not congruent, but that these angles and the sides have to stay congruent to each other. Okay, so once again, a way to reference that, like I talked about last time, was with the door, right? Okay, I said, hey, Mr. Titus' door is probably like the same size, dimensions as this door, correct? Mm-hmm. Like that'd be reasonable to say. Okay, yeah. And so let's just say it for sure is. Okay, let's say it for sure is. So if we think about these, the sides of a triangle, okay? So the actual door is one side, the door frame, where the gap is where the door is not there, is another side, and then the imaginary line connecting the door frame to the door, the edge of the door frame to the door, is a third line of the triangle. So then we have our angles created by these sides as well. Okay, boys, please stop. So this time we're saying we have one side length the same, and we have the two angles next to that side length. Okay, so let's say this side length is staying the same with the door frame, okay? Mm-hmm. Now let's say these angles have to stay the same. Let's think about what we can and can't do, okay? Would I be able to move this door at all?
No.
No, why would I not be able to move this door?
You'd be changing the angles.
Because then I change one of the angles it's talking about, right? And I change one of the angles we're talking about that says it can't change, okay? So I can't move that door, okay?
You can't do anything.
So we can rule that out. Could I then move this side as well? No, I can't move that imaginary side as well because that'd have the same problem on the other angle, okay? Could I maybe try and make maybe the door and the other thing longer, okay? Well, maybe like here, that'd be kind of like on the picture. Could I make these sides longer? Would that change anything though if I can't change the angle of it? No, because they're still intersecting at the same spot, right? So even though the sides are longer, they just keep going, but the actual size of the triangle doesn't change, does it? So, last time we talked about how if you have three sets of corresponding congruent sides, that's enough to prove the triangle is congruent. We don't need all the sets of sides, all the sets of angles, okay? And then we also said, well, if you have two sets of sides and the angle between the two, the included angle, hence A between the two S's, side, angle, side, that's enough. Well, now we're saying, if we have two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. Now once again, I want you to note that where is this side compared to the angles? It's included. What's that mean?
It's already there.
It's already there. What's that kind of? What else does it mean? It's what? Not necessarily. It's not that it's included in the information. I like that we're thinking and we're guessing, though. It's not that it's included in the information. What does it mean if someone includes you in a group?
You're a part of it?
You're a part of it, right? Mm-hmm. Now, if you're part of a group, okay, and you truly feel included in a group, are you probably going to be on the outskirts of the group?
No.
Where are you probably going to be?
You're inside.
On the inside of the group, okay? You're inside. You're in the group. You're in between, okay? So this included side is in between the two angles, okay? If you're included at someone's lunch table, you're probably going to be between a couple people, okay? If you're included at a lunch table, you're probably going to be between a couple people. If you're included in a group, you're probably going to be between a couple people, okay? Not during COVID. Yep, sorry. Distancing, okay? Now, so the included side is going to be between the two angles, okay? So that's very important. And if we notice, the way even the letters are structured in angle, side, angle, where is the S located? The middle, right between the two angles. That's very, very specific. Just like with our side, angle side, our SAS, okay? So, nice. So, letter A. We have these two triangles, A, B, C, D, E, F. Let's keep walking through. Last time we said, what do we know? What's something we know about these triangles, okay? What do we have, okay? Seth, what's something we have about these two triangles?
61 degrees.
Okay? Angles C and F are congruent. They're both 61 degrees, okay? Gregory, what's another thing we have?
D and F and A and C are congruent. Wait.
Okay, side DF and side AC are congruent. They're both 2.3 centimeters. Yeah. Okay, so we know we have a set of sides and a set of angles. Now, is a set of sides and a set of angles enough?
No.
Okay, no. For what we know, we would need either the side that would include the angle, or we need the angle that includes the side, right? Those would kind of be our options. Okay?
Yeah.
Or if we knew all three sides, which we just don't. Now, is there any way for us to know this any other sides right now? No, we don't know any side lengths, okay? So what are we probably going to try and look for?
The angles.
The angles, right? And which angle do we specifically need?
Angle B and angle D.
Okay, so angle B and angle D are the two we don't know.
A and B.
We specifically would need angles A and D to be congruent. Why would we need specifically angles A and D to be congruent for this to work?
The side would be in the middle then.
Because then the side would be in the middle between the two. It would be the included side. If we knew these angles, we'd say, okay, well, cool, but is the side between them? No, the side's not between those two. This other side is between them that we don't know anything about. So we need the side to be between these two angles. So let's say, how can we figure out what angle D is to see if it is congruent to 45 degrees?
You take 61 plus 74, add it up, and then subtract it by 180.
That's exactly correct. Chase, is that what you're going to say? Perfect, perfect. Teamwork. So 180, and we're going to subtract it with minus the 74 plus 61, which is going to be 135. 1 minus 1 is 0. 8 minus 3 is 5. Excuse me, but before we do that, let me go the other way. 0 minus 5 got a carry. 10 minus 5 is 5. 7 minus 3 is 4. That's better.
45.
So are these congruent?
Yes.
Yeah, they are. So now do we have enough information to say that these triangles are congruent?
Yes.
Yeah, we do. So now we can make a congruent statement. We're going to keep making these congruent statements. So can anyone help me make a congruent statement like triangle this, congruent to triangle this by blank? Okay? Elizabeth, go ahead.
Triangle ABC is congruent to triangle DEF by ASA.
Very good. Triangle ABC is congruent to triangle DEF by ASAR, angle side angle. Now, did Elizabeth have to say the first one was ABC? No. But since she chose triangle ABC for the first one, she had to call the second triangle DEF to match. Okay?
Or you just call it ABC again.
Then that'd be saying the same triangle is congruent to itself, so that's a reflexive property. Yeah.
So you just called it ASR, not ASA.
So you've been looking at Mr. Costas' case for a while.
You said you think you heard someone call it that, or you called it that?
I heard you call it ASR.
If I did, then I mistakenly said it. But it would be ASA. All right. Any questions on letter A? Okay. Let's look at letter B. And let's go and walk through the same thing of saying this. Hey, what do we know? And kind of go from there. Okay. What do we know? And we mark down everything we know and say, okay, well, what more would we need if anything else? Okay. Gregory, what's something we know?
Angle J and angle M are congruent.
Angle J and angle M are congruent. They're both 31 degrees. Okay.
I need another one.
Sure. Go ahead.
And then length of JL and EM are the same congruent.
Nice. The lengths of side JL and side PM are the same. They're both 62 inches. So those sides are congruent. Okay. So now we can say, well, we either need another side length that's going to go on the other side of the angle. So we can use side, angle, side. Or we would need another angle that would include the side. Well, do we have any chance at getting another side? Realistically, no. Okay? We really don't. So, well, how can we figure that an angle? What angle do we need to try to figure out here? Okay, we know angle N. We would need to figure out angle P. Why do we need to figure out angle P?
Because
Go ahead, Dylan.
No.
Okay, so Kenny's saying to prove the triangle's congruent. That's true. But why would angle P help us to prove that versus like angle K?
Oh, because we already have something in the place of K on triangle MPN.
Okay, well we already have something else in the place of P in the other triangle as well. So I like that you're thinking through here. But it's like, well, we have that there too. Okay, Greg, what are you thinking?
You can do 180 minus 31 minus 38.
Okay, so you're saying how do we find angle P, right? You're telling us how to find angle P. Okay, before we fast forward to how we find angle P, I want us to talk just to think about why are we finding this?
The side
Okay, because the side would be where, Seth?
would not be in between.
We want the side to be between the two angles. Okay, we want the side to be between the two angles. So is the side PM between angles M and N? No, it's between angles M and P. So we know that side. Okay, we know that angle. And like Gregory said, the math would be 180 minus 31 plus 38, which would be 69. Now we subtract here. 0 minus 9, we can't do that. 8 minus, so we subtract 1 from the 8, make it a 7, and borrow that to the 0. 10 minus 9 is 1. 7 minus 6 is 1. And 1 minus 0 is 1. So we end up getting 111 degrees. What does that tell us? These angles are not congruent. So now if we know for a fact that these angles are not congruent, can we say the triangles are congruent? No. And now, as a matter of fact, we had an issue on our homework, not an issue, but a question on our homework saying, well, Mr. Costello, I put not congruent versus not enough info. Well, not enough info is what you put when you don't know whether they're congruent or not. Because if you had more information, maybe they'd be congruent, maybe they wouldn't be. On letter B, is it an issue of how much info we have? No, it's an issue of what the info is. It's that 110 and 111 are not the same number. It's that those angles are not congruent. So here you can definitively say that these are not congruent. You can also do the congruent with a slash through it to say not congruent. And what would be something that could explain our reasoning here?
111 is not equal to 110.
Okay, you could say 111 is not equal to 110. Is there anything else that could explain our reasoning here? Elizabeth?
Angle P, angle L or not?
Very good. Angle P is not congruent to angle L. That'd be enough. Either of those. And there's other things you do, Gregory.
Same with angle K and angle. Wait. Oh yeah, angle K and angle N.
Yeah. Yeah, angle K and angle N are not congruent. Okay? We can end up figuring out that angle K is actually 39 degrees. And so you can also say, hey, they're not congruent as well. Or that 39 is not equal to 38 as well. That's enough to prove that, hey, they're not congruent. Because if any of your parts that correspond are not congruent to each other, triangles can't be congruent. Okay? Yeah, so any of those could work. So we have 4 different explanations there, and there's probably more you could use, okay, that I'm seeing that could work. Yeah, Gregory.
Is there any way possible where it can have like 39 degrees, but can it still have like the same length as the other triangle? You have that.
I'm trying to understand what you're saying. For this to be 39 degrees and this to be 38 degrees, but these both to be 62 inches?
Yeah.
Yeah.
So like they could be the same length.
They could be like basically the same triangle down to everything except for a couple angle measures, but then the sides would have to be slightly different as well. But they could have one side length in common, and that same side length that's congruent could be across from a 39 degree angle in this triangle and a 39 degree angle in that triangle. It would just depend on what the other triangles are, the other angles are, and the other side lengths are. Yeah. Yeah, this is actually an example of that. Yeah. So good time to ask the question when I have an example up of it. Any other question on this? Alrighty. Let's look at letter C here. Okay. What's something we know about these two triangles? Actually, we have 3 triangles here, right? We have 3 triangles in this picture. Where are the 3 triangles in this picture, guys? Okay, Elizabeth?
Triangle ABD.
Okay, triangle ABD right here in the pink. Okay, what's another triangle?
ABC.
Okay, thanks, Seth. ABC. Okay, someone else, what's a new triangle? Okay. ACD, yep, right here. So those are our 3 different triangles there, right? Okay. Now, these 2 triangles, then we're probably going to talk about which 2 triangles being congruent. Are we going to talk about the big triangle, ABC, being congruent to another triangle? No, probably those 2 smaller ones, right? ABD and ADC, or ACD, okay? Now, what's some information we know about these triangles right now? Okay. I want to see some new people answer this question, okay? Quentin. Okay, angle B and angle C are marked to be congruent. Very good, very good. That's something we know. Landon?
Angle D is 90 degrees.
Okay, angle D is 90 degrees for both triangles, right? So those are in common, okay? What's another thing we know about these 2? Okay, once again, I want to see a new person answer this, okay? Versus the same Gregory, Elizabeth, and Seth that have been answering kind of all of them. And I'm very appreciative to you guys for wanting to answer and participate. But I want to get some extra participation from people that are maybe are not raising their hand right now. Okay, Tyler, what's something else we can know about these?
Line B and C are the same.
I wouldn't say line B and C, but maybe segment BD and segment what? Yeah, those are congruent, right? Those both have 1 tick mark. Now, is this enough to prove these triangles congruent? Yeah, it is, isn't it?
Yeah.
Because if we go through it, do we have an angle, a side, and an angle?
Yeah.
And the sides between them?
Yeah.
Yeah, we do. Okay. So can somebody help me with my congruent statement here? Ryan, can I have you help me with my congruent statement?
Triangle ABD is congruent to triangle ACD.
Very good, very good. And what's our reasoning?
Angle siding.
Very good. So Ryan's correct there. Triangle ABD is congruent to triangle ACD by angle side angle, or ASA, okay? Now, Ryan didn't have to call the first triangle ABD. But because he did, the second triangle had to be ACD. Okay? Dylan? Yes, good luck.
I don't want you to have,
Okay. Let's look at...
Why are you looking at track?
Oh, that's where I have my note packet at. It's like kind of like my bench for the day.
We should do C.
We probably will. I'm deciding if I want to do B as well.
I think you should do B as well.
You should do B as well? Alright, we'll do B and C. Okay?
Because it reminds them of this one.
It's true, it's true. It's important. Alright, letter B. What's something we're given? What's something we know about these 2 triangles, okay? Elizabeth.
Angle A and angle C are congruent.
Very good. Angle A and angle C is congruent, okay? What's something else we know about these 2 triangles, Tyler?
Angle D and angle B are congruent.
We don't actually know that yet, unfortunately. It doesn't say that for us. We don't have any information that reveals that for us, unfortunately. Bailey, what's something else we know?
E is the midpoint of A and C.
Yeah, E is the midpoint of segment AC. Now, what's that mean? If E is the midpoint, what's that mean? What's that tell us?
Vertical angle is equal.
Okay? That what's equal?
Is A and C.
Okay, not necessarily A and C. Okay, Landon.
Line AE is equal to line EC.
Yeah, those segments are congruent, okay? It's the midpoint, and so it cuts it in half, okay? It cuts it in half. So A to E is going to be the same length as E to C. So those are congruent, okay? Now, Seth, what are you saying about some other angles we might know?
Vertical angle.
Which angles?
AB and DC are vertical angles.
AC, or AB and DC?
No. D and B.
D and B are vertical angles?
With C because of B.
What was that?
B is a midpoint, which makes it go into an axis.
I think you're maybe misremembering what vertical angles are. Okay, yes.
Wouldn't it be line BE and line DE?
Not quite. So we don't know anything about segments. The line segments are the sides BE and ED because we don't know E is the midpoint of segment BD though. Because if we knew that, then we could know. But unfortunately, we don't. Yeah, but I love that we're continuing to try here. Okay. Does anyone know maybe if these are a certain type of angles right around there? Anyone having their memory jogged by that?
Yeah.
What kind of angles are those?
No.
Vertical.
Vertical angles. It's the word Seth was saying. He was misremembering what they were was all, okay? Vertical angles form the X, right? So angle AEB would be a vertical angle with what angle? Angle AEB would be a vertical angle with what angle?
EDC.
Not EDC. EDC would be up here. DEB would be this straight angle there, so not that one. Angle DEC. 3 letters. The vertex has to be the center, the middle one.
Oh, wait.
Those angles, vertical angles, are 100% of the time congruent. Okay? Yes, Kenny?
So if a triangle, if 2 triangles have the same like letter for a point, does that mean those points are congruent?
A point can't be congruent to anything because a point doesn't have size or shape.
Yeah, I mean, I know angle. That's
Okay? If 2 triangles share an angle, then yeah, an angle is congruent to itself.
Okay, yeah.
Yep. So if we were to have an example like that, then yeah, those 2 angles would be congruent. Just like how when they share a side, it's congruent to itself. Okay? Any questions on this one so far?
No.
Okay, now, do we have enough information to prove these triangles congruent?
Yes.
Yeah, Chase, what method can we use? Angle, side, angle, our new one we're learning, right? So we can say triangle, it already gives us something to write. Triangle AEB is congruent to triangle CED by angle, side, angle. And so anytime I ask for a congruent statement, guys, this is what I'm asking for, okay? In that purple here, this is what I'm asking for a congruent statement. Every time. Okay? Questions on that? Okay. I actually want to go back to another example real quick. Back on this example, on example C previously. We had said this was by angle, side, angle, right? Now, could we actually know something about side AD? What can we know about side AD? It is a bisector, actually, because we do know this is half. Yep, it is a bisector. What's congruent? Okay, it's congruent to itself, right? What property tells us something's congruent to itself? The reflex property. So segment AD is congruent to segment AD. So, do we also have side, angle, side? Side angle. So could we use a different method to prove these as well? Okay, so sometimes you'll notice on these that there might be multiple methods you can use, okay? I just wanted to highlight that real quick, okay? Question on that?
No.
Alrighty, let's go on to example C here, okay? Example C, well, it's kind of a mess, okay? How many triangles, don't blurt, how many triangles do you think we see here, okay? Once again, don't blurt. I want to see the number on your hand. Okay, you can either make it loud and proud, you can hold it close to yourself if you're not as confident. Okay? Those who said 5 are correct. Okay? Here are the 5.
Where we go?
Right, nice. Here are the 5. Right here is 1. We have the mirror on the other side. We have this triangle down here at the bottom. We have this triangle there. And then our 5th one is this triangle here.
Does that mean they're congruent?
Not necessarily. They appear to mirror. How about I say that? Alrighty. Because if I do just say mirror, then that would. But if I say they appear to mirror, then maybe not. Now, what was the tip I gave before on these? I don't remember when they kind of overlap like this. I gave a tip one time.
Draw up on it and draw the triangle down.
Okay, yeah, draw, like kind of separate them out, right? Like draw them as if they're separate. Sometimes that can be helpful. Now, for some of us, it might not be. Some of us, it might be, okay? Those it's helpful for, I'd encourage you to do that now. L, J, M, and then our other triangle, L, K, M. And you might want to remember, Mr. Costa, what if I'm not quite as good of an artist as you? Okay? Well, and I would say, you know what? I think one day if you put enough effort into it, you can reach my level of artistic ability, okay? I do believe that's possible for everyone in here, okay? Believe it or not, that would be my encouraging word to you, okay? Is that everyone can reach this level of skill in art if you just put in the time and the effort, okay? So, what's some information we know about these triangles? Okay, Elizabeth.
Well, we know that triangle JLM is congruent to triangle KML.
The angles, right?
Yeah.
Okay,
Angle.
so angle JLM is going to triangle KML. Okay, and if we wanted to, we can mark that on our big picture as well. Okay, that'd be the whole big angle there. Okay, what's another piece of information we know? Okay, Gregory.
Angle JML is congruent to angle KL.
Okay, so I'll put that down there. Okay, in our picture, our big picture, they kind of be like this tiny little angle down here at the bottom right and this tiny little angle down here on the bottom left. Okay, so now we have two sets of angles. Is this enough information? No. What do we need? A side. Now, which side specifically would we want?
The one in between.
The one in between the two angles, right? Because then we could use angle, side, angle. Now, is there something we know about side LM? It's congruent to each other because they're shared, right? Anything's congruent to itself. So these sides are congruent to themselves. So are these triangles now definitively congruent? Yeah, Tyler, do you want to tell me the congruent statement? Oh, okay, how about you tell me the congruent statement and then you can. The congruent statement, triangle blank, blank, blank is congruent to triangle blank, blank, blank by blank, blank, blank. Got 9 blanks to fill in.
Part of it already gives you the answer on the question.
That is true. 6 of the blanks are freebies.
JLM is congruent to LPM.
Okay. Yeah.
Okay, so if you did JLM, okay, so you did like kind of no arc, 1 arc to 2 arcs. You need to follow that same pattern. So what's 1 arc, no arc, 1 arc to 2 arc? KML, right? Okay, so you could go that order. Okay, by what? What method did we use? Tyler, what method did we use? What? ASA, angle, side, angle. Very good, very good. Phone a friend, right? Okay. All right, good luck in the bathroom. Okay. Any question on this one?
No.
Yes.
Thank you.
What? A lot of school districts don't have this day off. Personally, I think it's good that we did some education in that during advisory. Hopefully your advisor did that. I know I did that in my advisory. And then hopefully in your history class, if you have it today or tomorrow, you do some education on that as well. I think there's a lot of value in having some sort of education about what Martin Luther King Jr. Day actually is about. Rather than just giving a student a day off where they're just going to sleep in and play video games and not actually do anything with the day.
Well, we have it
Now, if a student were to have the day off and then actually, remember or celebrate or educate about the day, whatever that looks like, then, great. But my personal opinion is that a lot of students probably wouldn't do that. And so I see it as more beneficial and actually celebratory of the day to actually be here. That's my personal opinion, though.
This year we have
But-
President's Day off instead of Martin Luther King Day.
I'm pretty sure we had Martin Luther King Day on school last year too.
We did, yeah. I remember we did, yeah. But
We
what?
were supposed to switch, but we didn't.
We had school last year. Yeah, we had school last year on that day. I'm not sure what happened with that. All right, let's go back to our previous examples here. Okay, here's these perfectly drawn triangles. I'm actually, just to brag how good I am at drawing these, I'm going to draw them again.
You mean how good you are at drawing them and then correcting them to make it perfect?
You can't do that with this. You can only do it in.
See, look how good those are.
Those are terrible.
Identical.
Terrible.
Okay, so we already know these are perfectly congruent, but let's just say, for example, they're not. Okay, let's just say the only thing we know now, we know these two angles. Okay, and we know this side over here. Now, what's different about this setup versus my last setup that I gave?
The line is not on the bottom.
Okay, the congruent side no longer is the bottom side. Okay, and what's that affect? If the congruent side is no longer on the bottom side, what's that affect?
It affects the sides. Just kidding.
Okay, it's no longer the what side?
The bottom.
Okay, it's no longer the bottom. We already said that word, so I'm probably looking for another one.
It's not the imaginary.
It's no longer the middle. What's our special word? It starts with an I.
Enter.
That doesn't start with an I. What's the magic word that starts with an I?
No longer the included side?
The included side. It's no longer the included side, right? Okay? These are, guys, what's off? These are two angles in the non-included side. This is not included. It's not part of the group. Okay? So let's go back over here to the door example again. Door, the frame, your imaginary line between them. So let's say we know these two angles again on the door frame. But this time the side we know is this door. The doors aren't going to change. Okay? And these angles can't change. Okay, well, I still can't swing this door anymore, right? Because then that changes the angle that we're not supposed to change.
Yeah.
Okay, so that's no go. Okay. I could theoretically make this side longer, right?
No.
Okay.
No.
Now if I
Well, I mean, you can. It just won't change anything.
okay, I could. I would just have to slide everything else out, right?
Mm-hmm.
Okay. So I could theoretically make the side longer. Okay. And then everything else have to slide out appropriately. Okay, accordingly. Now, if I were to slide that out, excuse me. Okay. If I were to slide this out a bit and extend that a bit, and then just push everything out a little bit longer.
Do you take away the flag?
That would take away the flag retention depending on how far I scoot it. Okay.
Just
And then
leave
we
it.
slide, and then we still try and connect this line. Okay. Well, I think what I'm trying to say here.
We'll be needing double.
Mr. Council, one of these times your iPad's gonna fall in the toilet or the trash can.
I really hope not.
I would laugh.
I think you should get a small bench there and move the trash can somewhere else.
Small bench.
I mean, I do have my stool I usually use. Just for today, like with me using the door example, I'm just over here enough, so I'm just setting it there.
Goonie.
Yeah, Gregory,
I know what you're trying to say.
you know what I'm trying to say?
Yeah.
Alrighty.
If you move the
Say it.
triangle,
Go
if
teach
you
your
move it
cousin.
to another location, it's still gonna be the same.
Okay. It's not what I was trying to say, but that is actually true, though. I do appreciate the input and trying to help me articulate what I'm struggling with right now. Okay. Let's look at this another method. Actually, let's go through another ones here. Okay. Now, if these two angles are congruent and these two angles are congruent, what do we know about these other angles? They have to be congruent. We had a theorem about that. It's called the third angles theorem. Okay. Because if you guys just give me a random measure, okay, Elizabeth, give me a random measure.
72.
Okay, cool. Let's call this 72 degrees. This one has to be 72 degrees as well, okay? Kev Dog, give me another random measure.
45.
Okay, 45. So we call this one 45. And that means this one has to be 45. So if we find out the third angle, okay, we're going to do 180 minus 72 and minus 75, which is going to be 117.
45?
Okay, 45. What did I say, 75?
Yeah.
Okay, it'll be 117, okay? And so we borrow, and we're going to get 63 degrees. Now, what's this one going to be up in the other triangle?
Has to be 63.
Has to be 63, because we're going to do the same subtraction problem, right? And assuming we did the subtraction right the first time and we do it right the second time, we'll get the same answer. Landon, turn around. Kenny, stop talking to him as well. Okay? Now, so we know that these angles have to be congruent, right? So now, if these angles are congruent, do we actually have angle, side, angle again?
Yeah.
We do, don't we?
Angle too.
Okay, we do have angle, 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 but we actually, that won't be enough for us to use, and we'll talk about that in a bit, okay? Remind me of that. So we have angle, side, angle. Now, we said angle, side, angle was enough to prove it, right?
Yeah.
So are these triangles congruent now?
Yeah.
Yeah, so if you ever know even just two of the angles, do you know the third angle automatically?
Well, yeah.
And then you can know, and then you can use angle, side, angle, okay? So instead of saying, well, every time if you know two angles and a non-included side, well, let's walk through and say, okay, well, I'll know these angles. Now I can use angle, side, angle. Instead of having to walk through those extra steps, because you do it every single time, we can just use the shortcut, angle, angle, side. We can use angle, angle, side. If two angles and a non-included side of one triangle are congruent to the corresponding angles in the non-included side of another triangle, then the triangles are congruent. Okay, so notice, where is the S compared to the two A's? It's outside of them, right? It goes angle, angle, then the side. The side's not between them anymore. Okay? The side's not between them anymore. It says, I'm out of here, okay? It's not included anymore. So let's look at this example here, okay? We're given that segment AC is congruent to segment EC. And we're also given that line M is parallel to line N. We're given that these lines are parallel, so we can draw an arrow to prove that. And we're trying to say, are these triangles congruent? Okay? Well, with these parallel lines, okay, Gregor, what's up?
With the parallel lines, couldn't you say that line AB and DE are congruent?
We can't say that for sure yet. We'd have to go through a few processes to get there. But yeah, I love the thought. Okay, Seth?
Angle DCE is congruent to angle ACB.
Okay, I would agree with that. Angle DCE is congruent to angle ACB, okay? What kind of angles are those? Vertical angles, right? Those are congruent 100% of the time, okay? So now this still isn't enough information, right? We need another set of angles if we want to use angle side. Okay? Now we're told these two lines are parallel, right? So do we have two parallel lines cut by a transversal? Does that ring any bells? Two parallel lines cut by a transversal? Okay, I really hope it does.
Definitely not.
Okay, especially if I cover up this other line here maybe for a second. And we kind of don't look at that. Okay? Look at these two parallel lines cut by a transversal. Are these angle EDC and angle CBA anything special? Mrs. Haswell thinks they are. What kind of angles are these guys? Anyone remember? Are they on the same side of this transversal? Are they on the same side of the transversal? No. So what's the word for they're on different sides? Alternate.
Would it be exterior?
Okay, well, let's think. Where are they compared to these parallel lines? Are they inside the parallel lines or outside of them? Inside, so they're alternate what?
Interior.
Alternate interior angles. And alternate interior angles are, in fact, congruent when the lines are parallel. Okay? So now, could we say by angle, side, and angle, side, if we kind of follow the pattern, can we say these triangles are congruent?
Yes.
Yeah, we totally can. Now we could say triangle ABC is congruent to triangle EDC by angle, side. Now, could we also say, well, these are alternate interior angles over here then, angles DEC and angles CAB? You totally could say those are alternate interior angles for using the other transversal as well. And now you could use angle side angle if you want. Okay? Here's a little tip for you guys. You might want to write this one in somewhere. Okay? Anytime you can use angle, side, okay? Anytime that you can use angle, side, you can also use angle, side, angle. Okay? Anytime that you can use angle, side, AAS, you can also use ASA or angle, side, angle. Okay? It doesn't go the other way. Okay? Or excuse me, no, it would go the other way, excuse me. Anytime you use one, you can use the other. Yep. Anytime you use one, you can use the other. All right, let's go on to number two, okay? I'm messing myself up here. I have this combination of something being A, B, C, and something 1, 2, 3. I might need to fix that. Alrighty. So on number 2, what's something we know about these two triangles? Angle A and angle B and angle D are congruent. Now these two triangles are on a coordinate plane, right? That's kind of different than what we're used to, okay?
270.
Okay, what'd you say?
I said it did it 270.
Oh, you're saying like a 270-degree rotation?
Yeah.
Okay. It would actually be more like a 90-degree rotation. Or I guess it depends on which one's the original.
Yeah.
So if this is the original, it'd be 90. If this is the original, it'd be 270. Yeah, okay. I feel you. Okay. Actually, it wouldn't be rotation. It might be a reflection. All right. And what's something else we can know about these triangles, though, since they're on a coordinate plane? Think about it for a second. Kevin's thinking hard here.
How big they are.
Okay. What do you mean how big they are?
Well, if you look, one of them's like 4 to 4.
Are you talking about the side lengths? Okay. So what's the side length you know right now, Dylan?
B and A are 4.
Okay. So side BA is 4. You just counted that, right?
Yeah, and
and EF of 3, okay? So you can count those, okay? Now, are we able to count side AC like that?
No,
Why not?
because it's diagonal.
It's diagonal, right? Okay, what's another side we can count, though?
BC is only 3, and then DE is 4.
Okay, so what can we glean or take away from this new information that we know these side lengths?
Side angle.
What do we know now? Do we know any more sets of sides or angles are congruent to each other? Okay, Gregory?
I don't know what that side's called. I think it's AC
Okay,
and DF. Or wait, sorry. AC is 4.
okay, we can't count that with a diagonal, unfortunately. We'd have to use either Pythagorean theorem or the distance form, okay? Elizabeth?
If I'm looking at it correctly, angle D and angle E are right.
Those are right angles, right? It's a perfectly vertical line with a perfectly horizontal line, so that would form a right angle, okay? So we know those are right angles. Okay, and now we mentioned side lengths, but did we mention any sides that are congruent yet? Because as of now, we don't have any sides marked as congruent. Are there any sides we can mark as congruent? Okay, Chase, what's something we can mark as congruent for sides? Yep. Yeah, and is that right there enough information to prove?
Yeah, that's side
Doesn't
angle
say
side.
proof though.
Yeah, you can prove it by not side angle side on the. Well, you could.
Sorry, angle side.
You could use angle side or angle side angle right now. Okay, and if we say side BC is congruent to side EF, could we now use angle side?
Yeah.
Yeah.
Okay, could you also use side angle side?
Yeah.
Yeah, so we have a lot of different methods we could use here, right?
Yeah.
Okay, so of the 4 methods we've learned, you can use 3 of them here right away. Now we might be able to use the 4th if we knew these lengths, but that'd be a lot more work. Okay, so triangle maybe ABC is congruent to triangle DEF.
Side, or no, not side.
We could pick.
Angle side angle.
Okay, we can do angle side angle. You could do angle side. You could do side angle side. Those are the 3 we know right now that we could use. Okay, follow with us. Candy Malchow. Soon of the week. All right. All right. Anyone have any questions on this one?
He's tied for picking two.
Probably.
Most of the work you don't know.
I would know. I got staff of the week last week. Come at me again.
That's not as hard as students.
Oh, are you sure?
There's 4 people. There's a lot more students than staff.
You have to wait longer though.
Or there's only one staff. Anyway, okay. Alrighty. Gregory.
I got 2 things to say. Wouldn't it be harder to do the work instead of giving it out?
Do the work instead of giving out. Man, if only I did the work. Man, if only like on the answer keys you saw me writing out the work every time, and like if you only saw me writing down the notes the same time as you guys write the notes down. Man, like if only I did the work too.
And
Okay.
imagine
Yes, you can use
having
restroom.
to plan for the day.
Yeah, like imagine, anyway.
And having to grade all the homework.
Yeah,
putting
yeah.
it in.
Yeah, you're right. I don't do anything. Yeah, Greg has got me. All right. We're going to skip number 3.
Also,
What's up?
do not drink this if you're pregnant.
Yes.
I drink it anyway.
Okay, when I get pregnant, I won't drink it. Okay. Let's look at our last one. Hypotenuse leg. Hypotenuse leg. Now it says this is what's the special note this one has on it?
I don't know.
Well, read it.
Triangles congruent only for right angles.
It says only for right, not angles, but only for right triangles. Now, why might hypotenuse leg only be for right triangles? Can anyone raise your hand if you have a guess? Anyone raise your hand if you have a thought as to why hypotenuse leg might only work for right triangles? Kenny, what are you thinking? Okay, Seth, what are you thinking? Okay, the example next to it is a right triangle. Okay, but why can't we use it with a regular triangle? Because they don't have a right angle. Okay, well, it doesn't say anything about right angle leg or hypotenuse right angle. What about that word hypotenuse? What kind of triangles have a hypotenuse?
The right angles.
Right angle.
The right triangles. Do non-right triangles have a hypotenuse? No. So, could you use hypotenuse leg if it doesn't have hypotenuse?
No.
No.
No. Okay, just like when we had like side, angle, side, you need 2 sides and angle between them. In a hypotenuse leg, you need a hypotenuse and you need a leg. Okay, so if you don't have hypotenuse, then you can't do this. So if a hypotenuse doesn't exist because it's a non-right triangle, then you can't do that, okay? So hypotenuse leg, okay, is special for right triangles only. If the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and leg of another right triangle, the triangles are congruent. Now, does it say which leg you have to have?
No, you need both of them.
Okay, it just says, does it say hypotenuse leg leg?
Nah.
No, it just says hypotenuse leg. So you need the hypotenuse, which is always going to be across from the right angle. And what else do we know about the hypotenuse? What else do we know about the hypotenuse? What do we know about the length of the hypotenuse compared to the other sides?
It's longer.
It's longer always. Okay, so it's always across from a right angle, and it's always longer. So you have to have the hypotenuse of each right triangle congruent, and then one of the legs.
A squared plus B.
Okay, that is a theorem for right triangles. Okay, so let's look at example A. Once again, we have quite a few triangles here. Raise your hand. On your hand, I want to see the number of how many triangles you see in letter A. Okay, so again here, I see 5.
What?
See this triangle, and this triangle.
The same as the last one.
And then I see this triangle and this triangle. Yeah, it ends up being really the same as last one, right?
Back to mix.
Okay. And these here are what kind of triangles the big ones are. What kind of triangles are these big ones?
Right.
They're right triangles, so they have right angles, right?
Yes, sir.
So we're probably going to be dealing with those two, I would think. Okay.
No, we're gonna do
So-
the small ones.
Now, let's try separating these again. Okay, you guys know that's kind of a thing that I recommend here.
Yes.
You don't have to, okay? If it works for you not to, then don't do it, okay? That's fine. What, are you just so blown away by my artistic ability?
No, definitely not.
Oh, okay, I got my hopes up.
Yep, you definitely did.
I don't know why.
W, V, or Z, and Z, Y, or Z, Y, X.
Darn it.
Are those also right angles? Or right triangles?
Oh, okay, like these like small little triangles? Yeah, those are also right triangles. Yep. Yep. Yeah, so out of the 5 triangles, 4 of them are right. One of them's wrong. Okay. Alrighty. So what's something else we know about these? We also know these side lengths, right? WY and XY. So WV and XY. I said WY. WV and XY. So for these right triangles, do we know a leg or do we know the hypotenuse?
We know one of the legs.
You know one of the legs. So we would need the hypotenuse, right, for hypotenuse leg. Elizabeth, what are you thinking?
Well, I was gonna say because line WX connect, wouldn't they be congruent?
Yeah, line WX is shared between them, right? So that's congruent to itself. WX is the same length as WX. So now do we have the hypotenuses and a leg? Hypotenuse, okay? Now that we have the hypotenuse and a leg, okay? We totally do. So now we can say triangle blank, blank, blank is congruent to triangle blank, blank, blank. Okay, maybe we call this triangle, I don't know. VWX is congruent to triangle YXW by HL, hypotenuse leg. Questions on that?
No.
Okay. Let's look at letter B here a little bit. Okay. Oh, Chase, do you have a question? Oh, yeah. Good luck. Okay. So we're given that J and L are right angles, and we're given that K is the midpoint of JL and MN. Okay. What information can we glean from that being the midpoint? Okay, Elizabeth.
That JKN, or the angle of JKN,
Okay. Okay.
the angle of MKL are congruent.
Okay, that is true. Okay, that's not something we necessarily glean from the midpoint thing, but that is 100% true because they're vertical angles, right? And vertical angles are always, always, always congruent. Okay, so that's very true. Okay, now we know 2 sets of angles, and we know this. So we're gonna see there's a couple ways we can go about this. Okay, and we're also told that K is the midpoint of 2 different segments. Okay, so that's what's something we can glean or take away from that.
Line JK is also just the line. Okay.
Yeah, we're gonna have line JK is congruent to segment KL or LK. Because K is the midpoint of J to L. It cuts it in half. Now, what else could we know are congruent? Okay, Elizabeth.
The line MK and line KN
Very good. Yeah, because MN, the K is the midpoint of those, okay? Now, here, even before I mark down that most recent information, we could prove this congruent using angle, side, angle, right? So just because it's a right triangle, it doesn't mean you have to use hypotenuse, leg. It just means it's an option, okay? So we could use angle, side, angle. But now that we know this information, do we now hypotenuse, leg, right triangles? Okay.
J and K is congruent triangles.
If you went J and K, you couldn't go. You'd have to start with a different letter.
Why not just use
Oh,
one side?
L K.
I mean, that's the one we have to prove
Okay.
anyway.
If you go J and K, you have to go L M K. Okay. Or we could use one provided to us, or we could use a different one entirely.
Correct triangle.
By hypotenuse leg, thank you.
How would I know?
By hypotenuse leg, by ASA, by whatever you want. You only need one of them.
Oh, you need both, right?
Do we though?
All right. Questions on that?
You should just hop around.
Okay.
You don't need to, like-
Real quick, guys. I want to go over what we can and can't use. Okay. And we'll talk about more explanations on what we can't use. Okay. I know up here it says side, side, side that we can't use, but that's not true because we can use it over here. What does it say on your paper? Side, side, angle, okay?
Side, side, angle,
Angle,
and
angle,
A.
And angle, angle, angle. So these are the 5 we can use. Side, 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 angle, side. We learned those last week. Angle, side, angle, 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 side, hypotenuse, side. We learned those today. The ones we can't use. Side, side, angle, and angle, angle, angle. We'll talk more about those next class on Wednesday, okay, for sake of time today. I don't want to take up the time today with that right now. Now, but let me just say this as a reminder of why we can't use these, okay? Every one of these involves a side, correct? At least somewhere in it.
Sure.
Angle, angle, angle doesn't involve a side. Can't use it. We need at least one side length, okay? Side, side, angle. If you flip that around, you get a naughty word. No naughty word in Mrs. Costa's room. Not allowed. Now, it's not the actual reason it's not allowed, but it is quite convenient as a math teacher. I don't have to try and police that word, okay? Now, that's going to be your helpful way of remembering which ones you can't use, and then any other combination you can, okay? Kenny.
So then, if you have two triangles, right, and they have all three sides are congruent on each one, but they have different angles.
Nope.
No.
Great question. Yep. If you know the corresponding sides are congruent, then you know the triangles have to be congruent. There's just no other way for it to happen.
I don't know, man. That was a pretty mediocre.
Pretty mediocre what?
Question.
I don't know about that.
I wouldn't say it's a great one.